big warm welcome to all of you. It's really lovely to have you here with us to do this functions course. And of course, I'm super chuffed to have Nicole here with me as my super amazing TA, without whom I would not be able to do this. So thank you so much, Nicole, for manning the chat and giving our matrix support and pointing out my mistakes, which I make quite a lot of. It's really awesome to have you here with us. So thank you very much for that. Anyway, matrix, really lovely to see all of you again. Is there anybody that's here for the first time? Hi, Kani, and I've missed it. All the names look familiar, but is there anybody that's new or this is their first lesson at Watobe?
Ma'am?
Yes.
Ma'am? Kani
yes?
is actually It's actually Kanyisile. It's me, Kanyisile.
Is it you, Kanyisile? Okay, all right. I thought it was you, but I wasn't 100% sure. Okay, so okay, cool. I'm glad you're back with us. That's really awesome. Anyway, just in case there are people that are new and they don't know the drill, we want this lesson to be as interactive as possible. So I get that you guys are in matric and you probably don't want to talk too much, but please do ask questions. If there's anything that I've said that doesn't make sense, or if I do make a mistake, which I do, please don't be afraid to point it out to me. I don't want you to be confused, and if I've done something silly, I'd rather know about it and fix it straight away. Okay, but please, no question is a silly question. Nicole knows an awful lot about maths as well, so you can ask her too. So yeah, please just use this as an opportunity to assist you with your studies as much as possible. Okay, well, let's get underway, and I'm going to do what I always like to do, which is start off by asking you, if you had to explain to somebody what a function is, would you be able to do that? Would you be able to say to somebody a function is a... Could you do that? Could you explain exactly what a function is? I mean, we've been working with them since grade 9, 10. Yes. Okay, so Cassandra says yes. Okay, so Cassandra, what would you say the definition of a function is? You can pop it in the chat if you want, or you can talk, even better.
A function is it can either be a parabola, a hyperbola, a line function, or an inverse function, and it can only be a function when it passes the vertical line test.
Oh, okay. All right. So that's wonderful that you know about the vertical line test. Well done. And all those things that you've mentioned, yes, are indeed functions. So that's also right, Aisha. A function has an input and an output. Quite right. So specifically, when we talk about functions, we're talking about a mathematical relationship between two sets of numbers. Okay, or it could be three sets of numbers, but for our purposes here, it would be two sets of numbers. An input and an output. Okay, and we know that our input we refer to as our domain, and our set of outputs we refer to as our range. And for functions and inverses, knowing your range and your domain is really important. It's something that does come up, and they do ask about that, which we will look at in more detail when we examine the specific inverse functions as well. I'm really pleased that Cassandra mentioned the whole idea about the vertical line test, because that's something that I want to talk to you about today as well. Is there anybody that has not done inverse functions at school? Have you all done Boitshepo? Okay, so does that mean you haven't, Boitshepo?
Yes, ma'am, we haven't. We're still on calculus. So.
Oh, okay, all right. No, that's fine. Michelle also didn't do it. If you can just give me an indication either through words or on the chat. Okay, thanks, Thelma. Thanks, Kumo. Okay, Morongoa did it, Kulani as well. Yeah, Belinda, thank you. Thanks, Lesedi. Thanks, Cassandra. Did it. Okay, Cassandra, Liam's done it. Can you see Lee's done it? Okay. All right. So most of you have done this, have done this section. Okay. Michelle, don't worry if you haven't done it yet. It is something that is generally taught in the first term. But for example, my school, we haven't taught it to our boys yet either. So it's actually the last thing that we do before final exams or before the trials actually. So don't be panicked about it, Thelma. Hopefully you, Michelle, hopefully from the discussions that we have here, you'll be able to follow even though you haven't actually done it at school. All right, so we were talking about the definition of a function and that it's a mathematical relationship between a set of input numbers called a domain and a set of outputs called the range. But a function is actually even more than that, all right? There has to be a specific link between input and output in order for it to be called a function, all right? Now, functions can be one-to-one, or they can be one-to-many, all right? Now, when we say one-to-one, we mean one input to one output, or one element of the domain to one element of the range. Functions can also be one-to-many, as I was saying. So that means one element or one value in the domain to many values in the range. Now, if you've done calculus, you would have examined one-to-many function when you did the cubic function. The parabola is another example of a many-to-one function. So I'm going to come back and I'm going to talk specifically about these, but here, an example of this would be your cubic function, and I'll show you why in just a little bit. And another example of a many-to-one function would be a parabola, which is what Cassandra was talking about in the beginning. Okay, so in order for it to be a function, there is a very specific relationship between certain elements in the domain and others in the range. So we will say that it is a function if one element in the range is associated with one element in the domain. So for example, if you have a look here, -2 is associated with 1. 4, an input of 4 gives an output of 6. An input of 5 gives an output of 7. An input of 3 gives an output of 9. So one distinct value in the domain produces another distinct value in the range. All right. In the case of, and these would be, sorry, I wanted to say this before I moved on. And for example, here, these sorts of functions would be your straight line, like y equals mx plus c, so your linear function. It would also be your exponential function. It would also be your log function. It would also be your hyperbola as well. So that's just some examples of one-to-one functions that we study. So let's go and have a look at the difference. Yes, Bochepo.
Ma'am, like when you're going through the functions, I'm like, is the log function have to do what's with the log function again?
Okay, so a log function is the inverse of the exponential function. And when you get to do inverse functions, it's one of the functions that you're going to study. So, and I will be talking about it on this course as well. So the idea is that if we've got an exponential function, so let's say I've got an exponential function that does that. And this is the graph y equals 2 to the power of x. When I do the inverse, it's like I have reflected the graph over the line y equals x. So what ends up happening here is that this graph is now sketched over there. And whatever was x is now y. So let's say if that was your y-intercept and the coordinates there were 0 and 1, it now has an x-intercept and it is now at 1 and 0. Okay, so it's a reflection of a graph over the line y equals x. So here, this is, sorry, let me just highlight it. The one that's in pink is a bog standard normal increasing function, exponential function where a is positive and b is greater than 1. And what I'm highlighting on the other side, let me just get another color, this green one over here, this would be a logarithmic function. So one of the things that I'm going to discuss with you is how we would write the equation for that, how we interchange x and y, and we use logs to make y the subject to the formula. Okay, but that's what a logarithmic function looks like. Okay, do you know, in fact, you know what's a really good example of a logarithmic function is now during COVID, when they kept on talking to us about flattening the curve. Do you all remember that? Flattening the curve. This is exactly what they're talking about, is this shaped graph. So like the COVID numbers were increasing, and then, you know, when we put these measures in place, then this is the flattening of the curve. That's what they were actually talking about. Okay, because pandemics are exponential, along with a number of other things in real life as well. Isn't that interesting? You know, like we learn these things and we think like, where does it actually apply in real life? And it really does. So that's why I actually love teaching the exponential function, because there are so many applications in real life. I mean, like human population, pandemics, even the way fire spreads, the smartphone use in the 21st century, all of these things can be determined through or are described by exponential growth. Anyway, I digress. My apologies. Let me get back to what I've actually been employed to do, which is to teach you functions. So if we contrast the one-to-one function, so one input with one output, with the many-to-one function, what we will see is that you may have one element of the range, of the domain associated with the range. But what you can have is you can have two elements of the domain associated with the same element of the range. That's why we call it a many-to-one, okay? Because this is the many bit, and then this is the part where it's one. Okay, so two different x values are associated with one y value. Now, how does that happen? Well, the parabola is probably the best example. Okay, so if we consider a y value of, let's go with 4 here as well, okay, can you see that it's going to have a certain x value over here, and it's going to have another x value over there? That's how two different parts of the domain, so on the x-axis, can be associated with the same element on the range, and that's what makes it a many-to-one function. Are we all feeling good so far? Is this making sense? Yes, okay. Please interrupt me or stop if it doesn't, but I want you to understand what it is that we're doing before we jump in and start doing all sorts of weird and wonderful things. Okay, now let's consider a situation. So we've got situation C here, okay, and situation C is kind of like the opposite of B. All right, in the case that, can you see we have got one element of the domain and it's now been associated with two different elements of the range. Now it is no longer a function. You cannot call it a function anymore. Okay, and that is because you've got two different y's for one x. So two different x's can have the same y, but one x can't have two different y's. Okay, so in this case, what we would do is we would call it a one-to-many relation. Okay, but very importantly, it is not a function. And the best example of this, I mean, if those of you that have done functions would know this already, is what happens when we reflect the parabola over the line y equals x. So I'm not drawing that exact one, but your parabola ends up looking like this, doesn't it? Okay, when it's been reflected. Ach, Jere, why is it doing that? You know, when I don't want it to draw straight lines, then it does. And when I don't want it to, it doesn't. Okay, there's my parabola. Okay, so now the reason why this fails, and this is what Cassandra was saying, the reason why this fails the test is because what we do is we actually draw a vertical line here. Let me draw the vertical line. Haha, there we go. Oh, with a little squiggle at the bottom because it couldn't be perfect, right? Anyway, okay, so here you can see we've got one element of the domain, one x value. And now you can see that it's associated with a different y value over there, and obviously a different y value over there. Okay, so the inverse of a parabola is no longer a function because it fails that vertical line test. I'm going to talk a little bit more about that now. There are two tests that we can do, the vertical line test and the horizontal line test. Okay, so when we do the vertical line test is there to test whether it is a function or not. All right, and it's very easy. All you do is you hold a vertical line over the function. So like what I've done over here, if we hold this, if I try and grab it now, come on. If I grab this line now, I would say that it's failing this function, well, not function, this relation that I've drawn is not a function because it fails the vertical line test, because the vertical line cuts the function in more than one place. So we can do that with all sorts of things. So for example, I've got these ones over here, and we can take this vertical line. So if we have a look at question B, is it failing the vertical line test? No, it's not, because the vertical line is only cutting our graph in one place. So that means that the graph that's been drawn is a function. Okay, similarly, if I want to now take this down, oh, I never get it right, do I? Okay, take it down here. Again, can you see with this parabola? Do you see how the parabola is passing the vertical line test? Okay, so the vertical line is only cutting the parabola in one place. That's why the parabola is a, well, it's not the reason, but it passes the vertical line test, and that means that it is a function. Now let's go and have a look at the circle. Look there. Okay, does the circle pass the vertical line test? No, it fails. All right, so that means that a circle is not a function. Is everybody happy with the meaning of the vertical line test? So the vertical line test is there to see whether it is a function or not. Are we all good, everybody? Cool, okay. The horizontal line test is if we want to see whether it is a one-to-many or a one-to-one function, okay? So in this case over here, if we go back and I do this, because the straight line cuts the parabola in two places, this makes it a many-to-one function, okay? However, if I now go to the straight line and I do my horizontal line test over there, it only cuts my straight line in one place. So that means that it is a one-to-one function. Does that make sense to everybody? Okay, and again here, if I grab my horizontal line, okay, I mean, obviously it fails the vertical line test, so it's not a function. Here, one-to-one function. If I go down here, here's my parabola. Can you see why my parabola is a one-to-one function? Because it only cuts in one place at a time. Okay, does that make sense to everyone? Let me just check the chat. Okay, everyone's saying yes, yes, yes. Okay, so that's how you would be able to tell whether or not it was a function. All right, now I've put this exercise here. I don't really know if it's necessary for us to do all of these questions. I thought maybe what we could do is just sort of do a couple of them orally before we. So maybe if it cuts the graph twice, it's not a function. That's if it's the vertical line. Okay, Boyd Shepo. All right, so in order for it not to be a function, the vertical line cannot cut the graph twice. So look at the circle. Can you see my pink line is cutting the circle here and here. So the circle is not a function. Are you happy with that? Okay, the horizontal line is there to determine whether it is a many-to-one function or a one-to-one function. So I've only got, no, here we go. We can use this one. So again, here, the horizontal line It only cuts this hyperbola in one place horizontally, so it is a one-to-one function. If I take my vertical line up here, all right, can you see my vertical line is cutting my parabola in two places? So that makes the parabola a many-to-one function. Okay, so if you want to, I can just write it here on the side for you. The vertical line test is it a function or not? Okay, so if it passes the vertical line test, then it's going to be a function. If it fails the vertical line test, it's not a function. The horizontal line test determines, is it a many-to-one function, or is it a one-to-one function? Okay, so in the horizontal line test, if it cuts twice, or even 3 times, as in the case of the cubic function, so if it cuts twice or more, that makes it a many-to-one function. And if it only cuts once, then that makes it a one-to-one function. Why? Why do this to me when I'm writing so nicely? One-to-one function. Cuts once, it would be a one-to-one function. Okay, so I've just summarized it there for you guys. So if you do want to come back and come and read this later, you absolutely can. Okay. Anyway, I hope everybody's all right with that. As I was saying earlier, what I thought we could do for these was just sort of discuss, is it a function? Isn't it a function? What does it pass? What does it fail, etc., etc. So perhaps we can just do a couple of these and then we can move on. All right. So let's grab our horizontal line. Okay, so if we test here, it's passing, isn't it? Over here, it's passing. If we take it up there, it's passing. All right. If we come down here, okay, so Boyd-Sheppel, because you haven't done this before, have a look now. Can you see how that parabola has been reflected over the line y equals x? So originally, and the others who've done this would know this, originally your parabola was located over there. The line y equals x goes through the origin, and when we reflect the parabola over that line, we end up with that shape. Okay, so that's why the inverse of a parabola is not a function, because it is failing the vertical line test. Circles too. Circles are not functions. Okay, they also fail the vertical line test. Here's an exponential function. You can see it passes the vertical line test. Even that semicircle does, as does a cubic function for those of you that have done calculus. All right, now the horizontal line, is it a many-to-one function or is it a one-to-one function? So again, here, can you see only cutting in one place? So it's a one-to-one function. Okay, here, look, can you see how it cuts 3 times? Okay, so that's what makes it a many-to-one function. That we know is not a function at all. Okay, again, a many-to-one function because it cuts twice. A many-to-one function because it cuts twice. A many-to-one function because it cuts twice. All right, are you guys okay with domain and range? Do you want to talk about domain and range a little bit? Yes, okay, all right, that's perfect. Okay, no problem. Now, how you choose to write the domain and the range for questions really is completely up to you. You can either do it using inequality notation, or you can do it using interval notation. Now, interval notation is the one with the brackets, okay? I personally, yeah, Aisha, I don't think we're going to be able to talk about when the signs swap today, but I will talk more about this. I promise. Okay. Today is just literally the basics. Is it a function? And we're going to get into it in our next lesson. But please do ask along the way. So when we are talking about inequality notation, we are describing either something that's in between or something that's smaller than this or something that's bigger than that. So if I say something like this, x, I don't know why this pen is doing this today. So irritating. Okay, so if I say x is greater than 1, I'm describing a specific place on the Cartesian plane. So in other words, if I was to draw a vertical line, and that's the line x equals 1, I'm describing the region to the right of that. Okay, so when we are talking about domain and range, we're talking about the input values and the output values. As far as your input values are concerned, when it comes to something like a parabola or a exponential function or a cubic function, we would simply say that x is an element of the real numbers. What that means is that the graph continues going in both directions forever and ever and ever. So it keeps going to negative infinity and it keeps going to positive infinity on the x-axis. All right. And that's what you would see in the case of all of these functions here as well. So, I mean, this line continues, even though it's going straight up, it continues to move to the right. And obviously there it continues to move to the left, as does this one. All right. Where the range becomes important is where functions have turning points. All right. So specifically in this case over here, when we are talking about a parabola, all right, if it is a parabola that is smiley faced, all right, it's going to have a minimum value, which means that once it's reached its minimum, every other output that's generated by the rule is going to be bigger than that. So for parabolas that are smiley faced, we would say y is greater than or equal to the value of y at the turning point. Now, in this case over here, the value of y at the turning point would be 0. But for this graph, the range would be different. Here it would be y is greater than or equal to -4. Okay, so that describes the set of output values. If I wanted to write that using interval notation, in my opinion, it becomes a little bit trickier. Okay, so with interval notation, if they're asking you for the range, you have to write y is an element of. And then you've got to use brackets. Now, if you have used the greater than sign or the smaller than sign, all right, this means that whatever value you're talking about is not included. And when we use interval notation, we use a round bracket. If we've used the greater than or equal to or the smaller than or equal to, then whatever value we're specifying is included. And to show this in interval notation, we use square brackets. Okay, so now if I want to say that y is greater than or equal to -4 using interval notation, I have to have a starting point and I have to have an ending point with my brackets. All right. I always put the smaller number on the left. So in this case, the minimum that this function can generate is -4. And because -4 is one of its outputs, I've got to use a square bracket. Every other number is bigger. So that means that it goes on to infinity. And because infinity is not a number, it's an idea, numbers go on and on forever, I can't include infinity. So that's always got to have a round bracket. So you can choose which way you want to write it. Either you can write it like that, or if you wanted, you could write it with the brackets. I personally think that having to try and remember the brackets as well is difficult, but some people prefer that. It's completely up to you. Okay. So yeah, so when they're talking to us and they want us to talk about the domain and the range, the domain is the set of inputs and the range is the set of outputs. Now, obviously, if you've reflected something over the line y equals x, your domain and your range are going to swap round. What was your domain is now your range, and what was your range is now your domain. But when I talk about inverses, I will discuss that in a lot more detail. How are you guys feeling? Is everything making sense? Okay, I think you will find that they will ask you for questions on range when it comes to parabolas and functions and stuff like that. They're not going to ask you for the domain. A question on the domain, like where there would be a restriction. So for example, in a hyperbola, then they would ask you a question on domain. So if we go up to this hyperbola over here, let's pretend that this is the function y equals 2 over x. Okay, and this value up at the top here is positive, and that's why the function is sketched in the first and the third quadrants. I don't know if you remember this from grade 10, but whoever taught you would have showed you that this value is obtained by multiplying x and y together. Okay, so y times x is 2. So when y is positive and x is positive, like it is in the first quadrant, that's why the graph is sketched here. And in the third quadrant, x is negative and y is negative. And that's why negative times a negative still gives you a positive answer. Okay, so that's why it's sketched in the first and the third quadrants when a is positive. All right, well, so when we want to make y the subject of the formula, we divide both sides by x, and that's where 2 over x comes from. In this situation over here, right, this graph has not been moved up or down, and it's not been moved left or right. So that means that if the asymptotes lie over the axes, right, so if I wanted to describe this function's range, I would say that y is an element of the real numbers, but that y may not equal 0. And you have to say both things. Okay, for a hyperbola. And exactly the same thing for the range. X would be an element of the real numbers, but x cannot be equal to 0. Does that make sense, everybody? So can you see what's happening, right? As the graph approaches the x-axis, it curves away and it gets closer and closer and closer, but it never touches. And again here, when it comes up from negative infinity and it approaches the x-axis from this direction, it curves off like that. It never ever touches the x-axis, and similarly it never touches the y-axis. But we know that in matric, well, certainly when we got to grade 11, they don't give us hyperbolas that have not been shifted. We normally have hyperbolas that have been shifted. So for example, if I draw a hyperbola that's been shifted to the right and then down. So for example, my hyperbola is now here and there. And again, I'm making up values. If this is the line y equals -1, and this is the line x equals 1, if I now were to describe, in fact, let's change that. Let's not make it 1. Let's make it a little bit more interesting. 2. If I now want to describe the range, again, I would have to say that y is an element of the real numbers. Now y cannot equal -2. If they asked me for the domain, x is an element of the real numbers, but x may not equal 1. Don't get confused. If they ask you for the equations of the asymptotes for this function that I've just drawn now, the equations of the asymptotes are the lines x equals 1, y equals -2. Sometimes what students do is they get confused with writing the domain and the range when they're writing the equation of the asymptote, and then we end up with something like that, which is like a combination of the two, but actually doesn't answer the question and makes no sense. Okay. All right, so I'm sorry, I'm just kind of like, there's so much to talk about with functions. That is because there is no restriction. You see, when you have an asymptote, can you see it means that the function is undefined at a particular value. Okay, so as far as a parabola is concerned, it's not undefined at a particular value. So here, with your hyperbola, division by 0 cannot take place. So that's why we cannot have x being equal to 0. Okay, that's why the graph can't touch the y-axis. And the reason why y can't be 0 is because you can't have, let me just change my pen, you can't have 0x equals 2. So there's no value that you could sub in for x that when you times it by 0 is going to give you 2. Does that make sense to you? Okay, so we would say that there's no solution. Okay. So this happens. So it happens with hyperbolas, it happens with the tan function, it happens with the exponential function. And with the exponential function, the reason why it happens, if we go down here to an exponential function, there's one over here, is because it does not matter how small x gets. This line is never ever going to touch the x-axis. Now, what is the reason for that? Okay, so if we think about values for x and y, inputs and outputs, let's pretend this is our bog standard y equals 2 to the x function. If we've got an input of -3 and then -2 and then -1 and then 0 and then 1 and then 2 or whatever, here we would say 2 to the power of 0, so that would give us a y-intercept of 1, so that would be 1 over there. 2 to the power of 1 is 2, 2 to the power of 2 is 4, 2 to the power of 3 is 8. Can you see the exponential growth? So this links back to what we were doing in sequences and series when we were talking about geometric patterns. Can you see that there is a constant ratio, okay, of 2 in this particular case? So now we've got 2 to the power of -1, which is the reciprocal with a positive exponent. So it's 1 over 2. And similarly, 2 to the power of -2 is 1 over 4. And 2 to the power of -3 is 1 over 8. And 2 to the power of -4 is 1 over 16. So can you see what's happening here, Matrix? These outputs, as we move to the left, are getting smaller and smaller and smaller and smaller, but they'll never ever be 0. That's why there's an asymptote. Okay, so because it does not matter what you make your input, you are never going to get 0 or a negative value as an answer. Okay, so that's why asymptotes exist. All right. Does that make a little bit more sense? Cool. Okay. I love functions. I could sit here all day and just talk about them, and I just, yeah, I love maths. I just find it's fascinating. But anyway, let's move on. I hope all of this has made sense to you. I just wanted to talk about all of these things, and obviously the vertical line test and the horizontal line test, but we will do this in a little bit more detail. What I thought we could go and do, because Most of us are pretty rusty on functions from grade 11. They teach us functions in grade 11, and by the time we get to matric, they just kind of expect us to know and remember everything that we've already done. So after having done that with you, what I wanted to do today was I'd taken some questions from past papers, so DBE papers that have been written at the end of the year, and I wanted to work through those function questions with you. And then in our next lesson and the following lessons, we're going to deal specifically with inverses. I hope that's okay with everyone. The first one that I wanted us to talk about together is this function over here. So straight away, when we look at that, f of x equals -1 over x minus 1, we look at that and we say to ourselves, okay, this is a what sort of function? What sort of function is it, matrix? Indeed. Thank you, Aisha. Thank you, Kanyasile. It's a hyperbola. And we know that it's a hyperbola by the way in which it's been written. Okay. The other thing that I know, before I even start answering any questions, there are a couple more things that I know. I know which quadrants it's sketched in. And I also know that a horizontal translation has taken place, and I know how many units that it has been translated. So now I'm going to ask you guys, which quadrants, is this graph sketched in? Indeed. Okay, so 2 and 4, that's it, absolutely. Okay, because the sign of A is negative. All right, so this is sketched in quadrants 2 and 4, and that's going to be important for us to bear in mind because they're going to ask us to sketch it. The other thing that we discussed is that there's been a horizontal translation. All right, so this particular hyperbola has been moved how many units and in which direction? How many units and in what direction? That's it. Very good. Okay, so it's been shifted 1 unit to the right. So even though it says x minus 1 here, it's been shifted 1 unit to the right. And that's because if we were to take x minus 1 and set it equal to 0, we would say that the axis, the equation of the, not the axis, the equation of the asymptote is the line x equals 1. So yes, can you see it has been shifted 1 unit to the right. Now there you go. Can you see? Look, write down the domain of f. Okay, so typical, they would ask you that for a hyperbola, probably not for a parabola, but for a hyperbola certainly. So what are we going to say here, matrix? We're going to say x is an element of the real numbers. Second bit, x may not equal 1, and that's what gets us our 1 mark. Okay, write down the asymptotes. Okay, now that's not a very nice way of phrasing things. They should have said write down the equations of the asymptotes, but fine. All right, so the equations of the asymptotes, remember there are 2 with a hyperbola. There's a vertical one and there's a horizontal one, always, always, always. So in this particular case, the vertical one is the line x equals 1. What's the equation of the horizontal one?
And if y is equals to 0.
Indeed, lovely, good job, guys. Very nice. Y equals 0. Okay, now we've got 2 marks. Good job. Okay, now sketch the graph of f, clearly showing all intercepts with axes and any asymptotes. Okay, so now they want us to sketch the graph. Before we do that, we need to decide, is there going to be a y-intercept or an x-intercept? So because this graph has been shifted to the right, it's now possible for there to be a y-intercept or x-intercept. What do you think? If the graph has been shifted to the right, the graph can now cut. Has it been shifted up and down? No. So in terms of up and down, it can't cut the x-axis. If it's been shifted left or right, it can cut the y-axis. All right, so in this particular case, It can cut the y-axis, cannot cut the x-axis, okay, because vertical translation has not taken place. So that means we need to calculate the y-intercept. For the y-intercept, we would let x be equal to 0. So we would say y is equal to -1 over 0 minus 1. Make sure that you sub in the 0. You're going to get a mark for that. And obviously -1 over 1 would give us 1, like so. Okay. Now that we know that, we can draw, check at this. I found this when I was playing around. So I'm pretty pleased with that. When you draw a graph that has an asymptote, you always draw the asymptote first, okay? So in this particular case over here, we're going to draw our vertical asymptote. You would obviously do that with a ruler. And then the other thing that you need to make sure of when you are sketching a hyperbola matrix, make sure that the two arms are a mirror image of one another. Otherwise, they can penalize you on the shape. Okay, now I'm going to try and do it here, but obviously on my sketch pad is not as great as what you could probably do in your books. And then here, that needs to be a mirror image. Okay, not too bad. All right, so the reason that it's out of 3, they are going to mark you on shape. So that includes which quadrants it's drawn in. They are going to mark you on the asymptote. And they're going to mark you on x and y intercepts. There's normally 1 mark for both. Okay, everybody happy with that? And now for the difficult question. So all of that was really easy. Now they ask us something a little bit more challenging. Have you all done, yeah, are there any questions? Good idea, Nicole. No, we all good? Okay. Cool. I always say this to the boys that I teach. Read this question to me. And then they all go, for which values of x will x times f prime x be great? And I said, no, 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 no. I know you can read. I don't want you to read it to me. I want you to tell me, what does it mean? Because it's only when we understand what they mean in maths that we can begin to unlock the question and access it, all right? So what do they mean by what they've written over here? What are they asking us to do? Yeah?
When are they asking for which values of x is y greater or equal to 0?
Almost, but not quite. You've got the one part right where you've said for which values of x, right? But can you see what they've done here, all right? They've got x times f prime x. Have you guys all done calculus?
Yes, ma'am. Okay, some of us.
Is there anybody who hasn't done calculus? If you can just talk quickly in the chat, have you done calculus, yes or no? Just quick. Yes, yes. Cool. All right. Oh, well, that makes things a lot easier for us, guys. Awesome. So all of you are familiar with what f prime x is. I mean, if I didn't know anything about maths, like at all, and I saw that, and I said to you, explain to me what that means, what would you say to me?
That it is the derivative of the function, the original function that we have.
Okay, but what's a derivative, Kanye? What does the derivative mean? Pretend I don't know anything about maths. So I say to you, okay, so it's the derivative of the function, but what is the derivative?
Ma'am, the gradient.
Exactly. Exactly. And Spares just put that into the chat as well. Perfect. It is the gradient. Okay, so f prime x, yes, it is the derivative. Absolutely, it is the derivative. Okay, a very good way of describing it. But specifically what it means is the gradient at a point. Okay, so in other words, how steep is the line at a particular x value? Okay, because all of these functions, apart from the straight line, are curves. So because they are curves, the gradient is constantly changing. So if I could measure the gradient down here, it's going to be a much smaller number than if I'm measuring the gradient up here, or if I was measuring it all the way up there. Okay, so along curves, gradient changes. So it tells us how the function changes with respect to x. So here in this question, x represents input. F prime x represents gradient. So really what they are asking us for here, Matrix, is they're saying to us, where is input times gradient greater than or equal to 0? So where is it positive? So they mean the values of these numbers, the value of the input, the value of the gradient. Okay, so input numbers, and when we're talking about to the left of the y-axis, input numbers are negative. To the right of the y-axis, input numbers are going to be positive. So the only way that we can get a positive outcome when we multiply two numbers together is if both are positive at the same time, or if both are negative at the same time. So in other words, we have to look for a particular place on the Cartesian plane, all right, to the right of the y-axis where we are climbing uphill. Or we have to be to the left of the y-axis, right? And here we need to be going, sorry, I wrote the wrong thing here. We need to be going downhill. Does that make sense to you? All right, so this one over here, you're looking either above or below the x-axis. Gradient, you're asking yourself, am I going uphill or am I going downhill? Okay, so I have to either be going uphill above the x to the right of, sorry, I wrote the wrong thing here. Right or left, sorry. It's input, sorry, it's right or left of y-axis. Okay, so either I have to be to the right of the y-axis going uphill, or I have to be to the left of the y-axis and I need to be going downhill. A hyperbola, like an exponential function, is only either going to be increasing or decreasing. It isn't a combination of the two like a parabola. So here, no matter where we measure gradient on any of these arms, this is an increasing function. So gradient is only positive. That means that we can completely disregard getting a solution from our second option. Okay, so wherever you are on the parabola, if you're walking to the right, you're walking uphill. Okay, that means we can only look at places to the right of the vertical axis, to the right of the y-axis, where our input numbers will be positive and we're walking uphill. So we have a couple of regions, all right? So we've got this area over here that is between, because remember, of course, your hyperbola can't touch the asymptote. And then we've got the area to the right of that, which is this area over here. Oh gosh, I need to touch the asymptote. Now, again, we need inequality notation or interval notation in order to be able to describe these regions on the Cartesian plane that we are talking about, right? So when it comes to the dark pink, can you see the dark pink is between? It's between the y-axis and the asymptote. So when we want to write between in maths using inequalities, we have to do it like this. So if I want to say x is between 2 or 3, I would have to write it like that as a compound inequality. So I'm going to have to do the same thing with the dark pink region. Now, this is a little bit trickier because here they used greater than or equal to. So the value of x to the left is going to be 0. Is it okay in this particular case for x to be equal to 0? Can I do that? Have I lost you? Yes. Okay, so I was asking you, is it okay in this particular function for x to be equal to 0? So, and the answer here would be yes. And the reason why is because our vertical asymptote no longer lies over the y-axis. Okay, our graph has been shifted. It's been translated 1 unit to the right. So it's no longer 0 that's the enemy. Okay, now 1 is the enemy. Okay, it can't be equal to 1. And that's why when we want to describe the dark pink region, we would say that the dark pink region lies between where x is equal to or greater than 0, but smaller than but not equal to 1. That describes this dark pink region. But there's another place on the Cartesian plane where this is happening, and that's the light pink region. So everything to the right of our vertical asymptote. Remember, our vertical asymptote is the line x equals 1. Okay, x cannot equal 1 in this case, so anything that is greater than 1. And that describes this part of the Cartesian plane. Okay, so that's why this particular question is out of 2 marks. There's 1 mark for that and 1 mark for that. If you wanted to write this using interval notation, what you would have to do is you would have to say where x is an element of, then here you've got to use a square bracket and put the 0 here. Then you've got to use the 1 and you've got to do a round bracket. And then you'd have to say or where x is greater than 1. Actually, you can write that in interval notation as well. If you use, you can use or, so the union symbol, and then here a round bracket by the 1, and then up to positive infinity, and then another round bracket. I personally think the pink is easier, but if you did want to write it using interval notation, you could do it that way as well. How are you guys feeling? I hope I haven't bamboozled you. Oh, I see. Sorry, ma'am, can you please repeat a little bit? Ma'am, could you please explain? Where did I lose you, Michelle and Kanisile?
Ali, I think that was the part when you asked if in this case can x equal 0. I think they didn't understand what
okay.
Yeah.
All right. Okay, but is everybody okay with why x can be 0 in this case? Okay, so there's thumbs ups now. Okay. All right.
And before you move on, Lee, sorry, Kulani
Yes.
asked earlier if it's necessary when you're sketching your graph to have a table of values to make the drawings, the drawing on the graph more accurate.
No, was it Kulani that asked that?
Yes, it was.
Yeah, Kulani, no, don't even worry about it. Even when you're drawing an exponential function, like normally, like when you taught that in grade 11, you would normally find like one other point so that you can make the graph 100% accurate, but you're not going to get marked on that. So I wouldn't even worry about it. What's important to show are turning points. So like on a cubic function, you've got to show the local max and the local min. On a parabola, you've got to show the turning point, and then you've got to show intercepts with axes. So any x-intercepts, any y-intercepts if they exist. And then of course, the other thing that you've got to show is on the graphs that have asymptotes like hyperbolas, exponential function, you've got to write down, you've got to draw and label the asymptote. Don't worry about a table of values. Okay. How's everybody feeling? Is this making sense? Oh, it's a pleasure, Kulani. Okay, cool. I think we have to do our poll tonight. Cool, Liam. Thanks, Michelle. Thanks, Boyche, Paul. You've been very brave to do this, even though you haven't done this section. But at least then when you do it, it will hopefully be a little bit easier for you. Do we need to do the poll, Nicole?
Yes, we do, Lee.
Okay, all right. Let's just do the poll before you guys go, please. Thank you. And of course, once you've done the poll, you're welcome to go, and we'll see you again on Thursday. Thank you, Matrix. Have a good week. It's a pleasure, Liam. There was a quiz that you did before this course started, but yeah, so there's no quiz today. Yeah.
It's just if you want to move to the foundations class that maybe goes at a slower pace, then you can do the quiz. But if you want to stay with Lee, then it's not necessary to complete that quiz.
Okay. Bye, Belinda. You too, Neo. Bye, Bochepo. Take care. Bye, Cassandra. Okay, are we done?
Yep. Oh, that lesson flew by. I was like, what?
It did.
I was wondering what you were saying about
yeah, no, the time just passed. Yeah, shame. It's difficult, isn't it, to try and get things so that it's right for you're not going to satisfy 100% of the people.
No.
You know,
and it varies every time.
It does. Yeah. And I mean, the thing is as well, is that, it's so difficult because I mean, like, you know, like with now, like with us, and they say to you, okay, you're now going to do a 6-lesson course on functions.
No. Yeah.
Talk about functions for 10 weeks, you know what I'm saying? There's just so much. I mean, like even now there was like a whole nother question down here that I wanted us to do, that we just didn't even get to this lesson. You know, there's just so much to discuss. So anyway,
Like, yeah, even what you discussed, there was a lot in there. So
there's a lot, hey? It's very
it's a
meaty.
lot.
It is.
Yeah.
Do you think it made sense though? Do you think I rushed it a bit? Because a few of them were saying a bit fast.
Yeah, I think it was just around the question, but I think it's a good start.
Okay.
I think it always goes well when you get the foundation right, so and the understanding. So
yeah,
I think the next lesson will be better when you consolidate with the questions and.
Okay. All right, cool. Thanks, Nicole.
Cool.
Thanks for your
Lee.
help.
Great job
Have
as
a good
always.
evening. You too.
You
Take
too.
care. Okay, bye.